So good morning everyone, we are on our next lecture on systems engineering. I would like to invite you as always to the webinars on the YouTube channel, Prof Webinar, when you can find all webinars and all lectures, not just about the system engineering but many others. So please be always on the time, and all our lectures is also recording, and you can find later on the webinars on the YouTube channel. So we are after the presentation of the fundamental knowledge about the system engineering, about the system approach, about the SEBoK, which is System Engineering Book of Knowledge. And last times we were talking about some implementations of methodologies and tools which are very helpful when we are talking about the areas of interest of the system engineering. And today we'll go through the next stages and next steps supporting by the system engineering, which are recommended by the SEBoK, which is System Engineering Book of Knowledge. So first, always we should start from technical requirements definitions process. So when we are trying to design the technical system or any other system, or when we are trying to analyze the system in terms of improvements, for example, or analysis of the problems, issues, or defects, we should always, especially when we are talking about designing the system, we should start from the analysis of the requirements in terms of system, because not all requirements by the customers or by the stakeholder can be covered by the system. We have to sometimes support the requirements, the cover of the requirements by other activities, not just the operation of this system. But of course, as much as we are able to support the requirements achievements by the system, it is good to have the as much as it is possible. So the recommended process when we are talking about the requirements definitions by the SEBoK looks like this. So we should start from analyze scope of the problem. And our problem is the technical requirements. Yes, then we should go through the two different ways, maybe not different but supplementary ways. First is to define design and product constraints, and second is to define functional and behavioral expectation in technical system. So it is what we should do at the very beginning. Then we should define the performance requirements for each defined functional and behavioral expectation. So it is mostly a situation that one single requirements generate few other requirements which not always is defined by the customer, for example, or stakeholder. Sometimes we have to analyze if one requirement is not generating different requirements which are, we can say, supplementary or additional function which has to be done to go with the first requirement. So as the input, what you should use on this stage of the process is the baseline stakeholder expectation. So it is what we should start, and after those two steps you should be able to generate the validated technical requirement. It is the first stage. Yes, it is, and it will be used for the logical decomposition, which you already done. Yes. You should also consider as the input the baseline concept of the operations, which can be also delivered by the process map, which you have been done last time. So after the second step, we have to go to the next step, which is define technical requirements in acceptable short statement, because not always the requirements which are defined by the customers or even by the designer are exactly the same and exactly the same way to present the requirements will help us to analyze the system when we are talking about the system engineering. Sometimes we have to translate from the customer language or designer language into the engineer language what does really this requirements needs when we are considering the system. So you should use for as the input for this stage the baseline enabling supporting strategies, and as the results you should be able to deliver the measure of performance. It is also very useful when you will go into the logical decomposition or technical data management process. So if you have already the defined technical requirements in acceptable statement, you are ready to go into the next steps, which is validate technical requirements and define measure of performance for each measure of effectiveness. Because when we are dealing with the requirements, when we are talking about the requirements, we have to also create the proper measure, the proper estimator, which gives us answer if the requirement is fulfillment or we have to do something extra. So, and because sometimes we are not thinking about checking if the requirement is covered by the system, we are just setting the requirements. But it is important to have the possibilities to check if it is already done. So as the result, you should have the technical performance measures, which is probably one of the difficult tasks, because as soon as you will be able to translate the technical requirements in acceptable statement, then you will be able to set up the performance measures. If you will not be able to transfer the requirements into the system engineering language, probably it will be difficult to find the proper way to measure if it is done. So as the last stage, we've got established technical requirements baseline as the results, and define technical performance measure. So it is what we should have as the results of the process of technical requirements definition process. Okay, so next important area of system engineering is logical decomposition. So you already did the logical decomposition. We have been using for the logical decomposition the work breakdown structure or product breakdown structure approach. So we will not talk too much in details about this. Just as the conclusion, you should remember that we have to define one or more logical decomposition models. One of those is work breakdown structure. Then you have to allocate technical requirements to logical decomposition model to form of set of derived technical requirements. So it is the place and the time when you will use the results of the technical requirements process. Then you have to resolve derived technical requirements conflicts. So you should apply here the first approach, the risk assessment, then validate the resulting of set of derived technical requirements, and as the last results is establish the derived technical requirements baseline. And it is the input to create mostly the graph of the logical decomposition work product. So it is what you already done. So it is just to remind you how you should analyze those important issues. So next steps and area when we are talking about the system engineering is design solution definition process. So how we can support the design solution definition process by the SEBoK requirements. So first, we have to set up the define alternative design solution. So as the result, you can use you should have the system specified requirements. Then you have to analyze, and it is much easier to done if you are after the two processes before this one. So we are after the technical requirements definition process. So then you have to analyze each alternative design solution, and by the alternative design solution you can consider different way of alternative solution. So first is, for example, the solution which will be more environmental friendly, and mostly we have the direction of new trend in the designing, which is the green design or eco design. So you are considering the environmental issue during the designing of the product or system. Yes, another alternative design solution is if we want to replace the materials, the component of the system, in terms of, for example, cost. So you should choose what should be the main factor when we are looking for alternative design solution. So then, as the result, you should have the end product specification requirements, which helps you to find out the alternative design solution, because not always and not everything is possible to do as the alternative way. So next one is select best design solution. So after analyzing few of alternative design solution, you should choose the best one, of course, according to the strategy, business strategy of corporation or the main task of our product. Then we have to generate full design description of the selected solution. As the input, you should use the baseline logical decomposition model, and as the output you should have the initial subsystem specification. So we've got all subsystems based on the logical decomposition, including the product breakdown structure, and you are able to generate the full design description. Then you have to verify if the fully defined design solution, so we have to define if the solution is correct, yes, if it is good. Then we've got the baseline design solution specified requirements and design description. So to prepare the baseline design solution specification requirements, it is good to use the baseline derived technical requirements, and as the results you should have the enabling product requirements. So you've got two possibilities what should have been done after the baseline design solution. So you can answer the question, is enabling products exist? Yes. If yes, you can go through the next stage. No, you cannot go through the next steps. You have to analyze and use the feedback and the reverse analysis. If no, you can initiate development of enabled product. The second question which should have been done on this stage is, need lower level product? If no, we should go back into the analysis. If yes, we should initiate development of next lower level product. So as the results of the total process of the design, complex process of design solution, you should have as the results the logistics and operations to procedures. So it is the important input for the next stages of the system engineering. So next area, when we are talking about the system engineering, it is the product implementation process. So we are after the stage of designing, we are after the stage of verification of our designing product or system. So we are in the stage when we are considering the implementation. So the SEBoK is recommend the process like this. So first we have to prepare the conduct implementation. We can use the three different approaches. So first is if implemented by buying, yes. If the answer is yes, so is participate in a part of specified end product. So we have to find out cooperations and collaborations here. The second is if implemented by making, yes. So if the answer is yes, we have to evaluate read lines of products implementation enabled product. And the third possibility is if implemented by reuse. Yes, if yes, so participate in acquiring the reuse end product. So it is different strategy which should have been considered when we are talking about the product implementation. So the next step is to make the specified end product, then prepare appropriate product support documentation, and as the foundation, as the results is capture and checkpoint is capture product implementation work product. So what can be used as the input information in the product? It is required raw materials. It is the base knowledge when you will consider if you will do it by buying, by making, or by reuse. Then the end product design specification and configuration documentation, and then the product implementation enable product. And as the results for the next steps of the process, we've got desired end product, we've got end product documents and manuals, and we've got product implementation work products. So it is the final documents, the final results which should be delivered by the process of product implementation process. Next area of system engineering to supporting the system designing is product integration process. So after analyzing of implementation possibilities, we have to answer the question how to consider the integration process. So to conduct product integration, we have to start from obtain lower level products for assembly and integration. So it is important because we have to have full knowledge about the all market when we are dealing with some devices, assemblies of subsystems for our product, and we have to be able to measure and quantify the quality, the availability of all subsystem assemblies devices which will be needed. Next step is to confirm that received product have been validated. It is important because if I am considering the integration of the product by integration by different assemblies, I have to be sure that all elements of the product was validated positively. So it is important also. So what I should use it as the input for this stage is a lower level products to be integrated, the list of the products, and as the results I should select which will be the assemblies for me, so I will have the desired product, yes, with product verification process. I will use it to the verification process. The next step is to prepare the integration environment for assembly and integration, because not always the only thing, and it is, we can say even often, not only issue is to find out what kind of assembly, sub-assembly I will need, but also what are the requirements for the integration, including influence of the environments for assembling. So we have to consider all those important information. So I should have the end product design specification and configuration documentation when I can find information which are needed on this stage. And when I've got it, I am able to go into the next step, which is assembly and integrate the received product into the desired end product according to the desired product verification process. Yes, so as the result, I should have the product documents and manuals, which are important because it shows you the all documentation and all manuals which are needed for the product to prepare all the documents of the product. And the last step of the process is to prepare appropriate product support documentation. We are not talking about just the production, but also supporting the product documentation. So as the input, you should use the product integration enabled product, and as the output, you will have the product integration work product. So everything is about the capture product integration work products according to this process. According to the SEBoK, which is System Engineering Book of Knowledge. Okay, so next stage, next area of system engineering should be the product verification process. We already talk about shortly in few times. I did mention about the verification. After the verification, about the validation of the process and of the product. So it is how we should do it. It is the process recommended by the SEBoK. So we should start from the preparation to product verification. So I would need the end product to be verified, yes, and it is from the product implementation on the product integration process. So as the results of our previous process, and as the results, I should have the verified end product, which I should deliver to the product validation process. So it's the next process. So the next step is to perform the product verification. As the input information, I should use the specified requirements baseline already described. The next one is analyze the outcomes of the product verification, and as the result, I should have the product verification results. So it should be useful for the technical assessment process. Next step is to prepare the product verification report as the results of the previous operation. So I should use the product verification plan. I should check if I would go with all steps of the verification plan, and then I am ready to deliver the product verification report to the technical data management process. So again, everything is about the capture the work product from product verification, basing on the product verification enabled product, and as the resulting give the product verification work product. So it is the verification process, and the next process is validation process. So it is product validation process according to the SEBoK. So it is how it should look like. We should start from preparation to the conduct the product validation. So we should have as the input the end product to be validated as before, and as the result we should have validated end product, yes, and it should be delivered to the product transition process, which will be the last process presented today. So next step is to perform the product validation. I need to have the stakeholder expectation baseline, yes, because it is the way how I will compare and I will assess if the product is good. Then we've got the next operation, which is analyze the outcomes of the product validation, about the whole process of validation, and as the result, I should have the product validation results, which should be delivered to the technical assessment process. Next, the last step is to prepare the product validation report, again based on the results of the previous operation, and I should use the product validation plan to as the checklist, yes, for the preparation of the report, final report, and as the output results, I should have the product validation report, which should be delivered to the technical data management process. So everything again is about capture the work products from the product validation based on the product validation enabled products, and to generate the product validation work products. So it is, as you can see, very similar process approach between the verification and validation, but we are talking about the different baselines, because right now we are talking about the stakeholder expectation, and it is about the validation of the product. The next area is product transition process, and the process required by the SEBoK looks like this. So we should start from preparation to the conduct product transition. The first step is to evaluate the end product, personnel, employees, and enable product read lines for product transitions. So what do we need it? We need on this stage the end product to be transitioned, and as the result we should have delivered end product with applicable documentation, which should be to the end user, to the customer, to the product integration process. We should use this documentation as the recursive loop also. So the next operation is prepare the end products for transition. And the next one is transition the end product to the customer with required documentation based on the type of transition required. So it is about combine all together which is necessary to satisfy the customer by the product, including the documentation. So what do we need as the input? It is documentation to be accompany the delivered end product. And as the result, we should have the product transition work product. It should be delivered to the technical data management process. So last step is to prepare the sites as required where the end product will be stored, assembled, integrated, installed, used, or even maintained during the exploitation. So what do we need as the input? The product transition enabled products, and as the final we've got the release enabled product. So it is to cover all life cycle of the product and all delivery stages of the product to the final customer. Okay, the next area in the system engineering is technical planning process. So it is important process. So we should start from preparation to conduct the technical planning. We would use the project technical effort requirements and project resource contains, and as the results we should have the cost estimators, schedule and resource requests. So it is important documents which will be used when we will start to finalizing the final project, which is the project of designing, prototyping and manufacturing the project which should be done. So the next operation is to define the technical work. I should have information about the agreements, capabilities, needs, applicability, products, and life cycle phases of the product, including all phases in life cycle of the product, starting from designing, manufacturing, distributing, and exploitation. So everything, and even right now we should consider the reverse logistics and eco-environmental issue. That is how very often we are using right now the life cycle assessment, the standard, which are more commonly used when we are talking about the life cycle analysis. So next operation is to schedule, organize, and cost the technical system. So it is extremely important information which should be mentioned in the product and process measures. Yes, so we have to control the process. Then we have to prepare the system engineering management process and other technical plans. Yes, so it is the system engineering management plan and other technical plans. We should use the policy, the procedures, standards, organization process, everything which is important for the management process and management plan. And the next operation is to obtain stakeholders commitments to technical plans. So we should also have the commitments of the stakeholders based on the prior phase of baseline plans, and we should have also as the results of both operations the system engineering management plan and other technical plans as the final report. And the last operation is issue authorized technical work directives, and as the result you should deliver the technical work directives. So everything again is about the capture technical planning work process according to the replanning needs, and as the results we should have the technical planning work products. So when we are talking about the system engineering, especially system designing, on every step And every stage I should be prepared to conduct the risk analysis, the risk assessment, because when I've got the proper methodologies, proper tools to conduct the risk assessment, I am ready to also apply the risk management. So it is what is required by the system engineering book of knowledge. So first we should prepare the strategy to conduct technical risk management. So we should decide what strategy we will use to reduce the risk, to minimize the risk, or to approve the risk. It is at least those three which can be chosen. So we should have the project risk management plan. The next step is to identify technical risk, which will be probably supported by the even one operation before, because before I will identify the technical risk, I should analyze all hazards in a process. So first I should analyze I should define the hazard in the system and the process. Then I should be able to quantify the hazards in my system, and after the hazard identification we can go into the identifying the risk, because there is the differences between the definition of hazard and the risk. So what I recommend on this stage of investigation of the process of risk management, I would recommend before the identification of technical risk to use the DHI, which is Deep Hazard Identification. It is the methodology developed by me, and you can find this methodology well defined in the book on epidemic risk analysis and assessment in transport services. So you will see what are the foundation on the deep hazard identification methodology, and we will talk about this also during our next lectures. So after identifying the technical risk, and by the way, the DHI methodology, deep hazard identification methodology, is based on the process approach. So you are after the lecture and workshop on process approach, so it will be much easier for you to adopt this methodology. So as the results of the identification of technical risk, we should have the technical risk mitigation or contingency action. So it is what we should have as the result. Then we should conduct the technical risk assessment according to our strategy. So we should have the technical risk issues according to the previous operation. Next one is to prepare the technical risk mitigation. So idea how to minimize the risk, or how to even reduce the risk. It would be, of course, the best strategy if I am able to reduce the risk, but if not, I should mitigate the risk. If it is also not possible, you have to accept the risk, and you have to know what are the results of the risk. So it is a huge decision right here, but you should be able to do it. So as the report, we should have the technical risk reports. So and what is important on this both stages, it is what kind of methodology you will use to assess the risk, because it is not just about identifying the risk, it is also about the quantification of risk. Yes, and it is also, I would also recommend you the methodology which is presented in the book of epidemic risk analysis and assessment in transport services. You can find out there the good multiplicator of the risk assessment, which take into consideration at least 3 or 4 different issues when we are talking about the quantification of the risk. So everything about proper scale and about proper approach. So then if you've got all those steps done, you are ready to monitor the status of each technical risk periodically. So we should conduct the risk management process not just one. It has to be constant process, and it has to be it has to be done every single time according to the plan of technical risk analysis. So you should have the knowledge in the technical risk status measurements, yes. And next, after the monitoring of the risk, of course, the risk monitoring system is about identifying the risk, quantifying the risk, and then decide about the decision about the proper action according to the level of the risk. So it is how we will use the monitoring of the risk. So next, last step is the implementation, technical risk mitigation, and contingency action plans as triggered. So as the results of the technical risk management process, we should have the work products of technical risk management, and it should be delivered to the technical data management process. So again, everything is about the capture work product from technical risk management activities according to the technical risk reporting requirements. Okay, guys, so I think that it would be enough for today. So I would like to invite you to the workshop. Thank you for your attention.